Hi everyone and welcome to Lab 7 Static Route Configuration. So in this lab, we will configure the static routing using this topology and we will performing these 6 tasks. But first of all, let me clarify and explain that why use static routing. So routing can be done either through static manual configuration or using dynamic routing protocol. So static routing is used where you have a simple and small network such as this one, and it offers us many advantages such as simplicity. We can configure it with minimal resources and predictability, and it does not have any overhead as compared to the dynamic routing where we have regular updates of routes. It is static and manual, and once configured, it remains as such unless changed by the administrator. It is also more secure because you know your destination, your next hub, and you can configure specific routes as compared to the dynamic route where big routes and big networks are learned by the routers themselves, and it is also cost effective for the smaller network. So some of the limitation of the static routing are that it is not scalable. It can be used for smaller and manageable network, but once network grows, it is not so scalable and becomes cumbersome, and that's where we use dynamic routing. And secondly, that you have to do everything manually. You have to add, delete, and configure the route manually as compared to the dynamic routing protocols. And third limitation is that it is not adaptable to the link failure as compared to the dynamic routing. So now let's go to the actual task. The first task is to assign the IP addresses to our clients, which is PC1 and laptop 1. So we'll assign these IP addresses. Both these are in different networks, and these, beside the IP addresses, we'll also assign them the gateway, which will be basically the interface of the route facing the client. So let's start the configuration. First of all, let me assign the gateway, which is 192.168.1.1, sorry, 1.254. So this is the gateway, and IP address is 192.168.1.1, and subnet mask is 255.255.255.0. And let me assign the gateway and IP address to the laptop as well. So the gateway is n.1.1.254, and the IP address is n.1.1.1, and subnet mask is 255.255 and 255.0. So that's it. We have assigned the IP addresses to the clients. So we can also configure the switch, but it is not needed in this simple topology. So we will leave the switch in its default configuration and it will do the work. If we had multiple VLANs and multiple clients, then we had to configure the switch to assign interfaces to different VLANs and create different VLANs, and the configuration on the router will also be would have been different. In that case, we had to configure the router on a stick as we did in our previous lab, but in this case we will simply assign the IP addresses to the router interfaces, and which is task 2. So the task 2 is assigning the IP addresses to R1 interfaces. So we will go to the CLI of R1, enter, and I will go into the global configuration mode, and first of all I will change the host name to R1, and now I will assign the IP addresses to the R1 interfaces. First of all, I will assign the IP address to gigabit interface 00. So interface gigabit 0/0 and IP address which is 192.168. This is the IP address that I will be assigning. .1.254, and the subnet mask is of course 255.255.255.0. I can also give description to this interface that is to or towards switch 1. This is connected to switch 1. So by default, all the router interfaces are in shutdown mode. So I will enable it, and the interface has come up. Now I will assign the IP address to its second interface, which is gigabit 0/1. So I will go to the interface 0/1, and the IP address that I will be assigning is 172.16.1.1. So IP address 172.16.1.1, and the subnet mask is 255.255.255.252, and I will also enable this interface, and I will also give it the description to R2. This interface is connected to R2. I will save the configuration. So we are done with assigning the IP addresses to R1 interfaces. Now I will do the same configuration on R2. Go to the CLI. We will go into the user privilege mode and then the global configuration mode. First of all, let me change the host name to R2. Now I will configure its interfaces. First of all, I will configure the interface that is connected with switch 2. That is interface gigabit 0/0, and I will assign it the IP address 10.1.1.254 written over here, and the subnet mask is 255.255.255.0, and again I will enable it. It is in shutdown mode. So as you can see, the interfaces has come up. I can also give it description to switch 2, and now I will assign the IP address to its interface gigabit 01. So I will go into the interface gigabit 0/1. I will assign it the IP address 172.16.1.2, and subnet mask are 255.255.255.252. I will also enable it, and I can also give it description to R1. I will save the configuration. We can use both the commands write memory or copy running configuration, startup configuration. Both are equal and good. So now we can see that all the interfaces are up, and we have done with the task 2 and task 3. Now let me ping the laptop from PC1 or PC1 from laptop 2. Let me go to the desktop, command prompt, and let me ping the laptop IP, which is 10.1.1, and it is not pingable. It is also giving us a clue that router is saying that destination host is unreachable. This is, remember, the router IP. It is because we need to configure static route on this router R1 for this specific destination. And if I ping my router IP 1.254, so it is pingable. So we can reach over here, but to reach over here, we need to configure a static route on router 1 to tell it that in order to go or to reach this destination, your next hop is this router R2. So our task 5 and the important task that this lab is about is the configuration of the static routes on both R1 and R2. So first of all, I will go to the router R1 and I will go to the global configuration mode, and now I need to configure the static route for this network 10.1.1.0/24, and this will be my destination, and my next hop will be this router R2, this IP, which is 172.16.1.2. So this is how I will configure the route. The command is IP route, and next I will give the destination, which is 10.1.1.0, and the subnet mask of the destination, which is 255.255.0, and then the next hop. So on router 1, my next hop is router 2, gigabit 01 interface, which is 172.16.1.2. 172.16.1.2, and that's it. So I have uh, done with this static route. Now I will also configure the static route on R2 so that laptop 1 can reach PC1. So on R2, we'll go to the global configuration mode, and my route will be, I am configuring the route for this destination, that is 192.168.1.0, having the subnet mask of 255.255.255.0, and my R2 next hop will be R1 gigabit 01 interface having IP address of 172.16.1.1. So I will give the next hop IP 172.16.1.1. Let me save the configuration. And now I will test the connectivity again. I will again ping the laptop from PC1. First packet may be timed out because the routers needs to learn the MAC addresses of these destinations. So we can see that the laptop 1 is now reachable, and if I ping the PC1 from laptop 1, it will also be reachable 192.168.1.1. So sure enough, PC1 is also reachable from laptop 1. So that's it for this lab. In the next lab, we will see the dynamic routing, and we will specifically configure and study the dynamic routing protocol OSPF, Open Short Test Path first. So stay tuned, subscribed, and see you in the next lab.